Today we're going to continue with our congruence postulates and theorems. Yesterday we talked about side, 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 angle, side, and we introduced hypotenuse, leg. I'm going to go over angle, side, angle, and angle, angle, side today, and then I'm going to go back into the video and talk about hypotenuse, leg for 5th period. That we did not finish hypotenuse, leg in 5th period. So I'm going to go back at the end of the video and do that. 4th and 6th, you don't have to watch the part on hypotenuse, leg because we made it through those in your class. All right, the first one we want to talk about today is angle, side, angle. And I'm pull up so I can take notes here, the workspace. And what it says here is if we have two angles and an included side of one triangle and two angles and an included side of a second triangle, then the two triangles are congruent. So what would that look like for us? So if we were just to sketch it out here, we'd have two angles and the included side. So an angle, and the included side would be congruent to an angle, and the included side. So that's what we're looking at here. Angle, side, angle. So angle, tick, double angle. And then the other one we're going to talk about today is angle, angle, side. So for this one, we would have an angle, and a side. We would have an angle, and a side. And once you pick one, you got to go around in the same order. So if I start with the single here, it's angle, side, angle. Got to go around in either clockwise or counterclockwise order. We can't skip around when we're naming the type of congruence postulate or theorem we're using. And there's also a reminder here that if we have two parallel lines cut by a transversal, then the pairs of alternate interior angles are congruent. Well, we know alternate interior, alternate exterior, same side interior, or supplementary. We know lots of things about two parallel lines cut by a transversal, but this is a reminder about the alternate interior. Example 8, can the triangles be proven congruent with the information given? So if I decide to start here, and I'm going in a counterclockwise motion, it's angle, angle, side. One tick, one mark, two marks, one tick. Okay, now is this congruent? Well, can I do the same thing, but in this direction? Angle, angle, side. Yep, angle, angle, side, angle, angle, side. So these can be proven congruent by angle, angle, side. Let's look at these. Are these two congruent? We've got an angle and an angle, and an angle and an angle. We also have a third angle, actually, because of vertical angles. Now let's think about all the ones we've studied. Side, 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 angle, side, hypotenuse, leg, angle, side, angle, and angle, angle, side. Those are all our valid congruence postulates and theorems. Well, this is angle, 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 or just angle, angle. So we cannot prove this congruent. We can prove these two similar, but not congruent. What could we do to make it work for one of these? Well, if I put a tick mark here or here, now it works. I've got angle, side, angle. Or if I knew that this was congruent to this, now I've got angle, angle, side, angle, angle, side. But with what we were given, there's not enough information to prove congruent. Cannot prove. Okay, now let's look at this one. We've got these triangles that are attached, and we have these vertical angles here. Whenever you see vertical angles, you can mark them congruent. Now if we look at this, I have an angle, a side, and an angle, and a side, and an angle. So yes, I can prove these triangles are congruent by angle, side, angle. And if I were to write the congruent statement, if I started with triangle ABC, we have to think about what is the corresponding angle to angle A. Well, that's our one arc over here, so we're going to start with E. And then we went A to B, so now we're going E to B, and then C. So these are our our congruent statement for this figure, which we can prove using angle side angle. Now if we look at this final proof, it tells us that we are given angle G is congruent to angle B. So go ahead and mark that on our picture. Angle G is congruent to angle B. We also know that CB is parallel to GA. We use the arrow symbol to mark parallel on our graph. So if you look at this, we have two parallel lines here cut by a transversal. We know that alternate interior angles are congruent. So this is on the inside of the two parallel lines connecting to the transversal. So this angle is congruent to that angle. So now if I look at it, I've got an angle and an angle, an angle and an angle. Well, I need a side somewhere. So hopefully we notice that CA is congruent to itself. So I've got an angle, angle, side, angle, angle, side. So I can jump to my proof statement and go triangle GCA is congruent to triangle BAC by angle, angle, side congruence theorem. Now let's fill in the blanks. We always go back to the given. My first statement, angle G is congruent to angle B. Why do we know that? Given. Then I know that CB, segment CB, is parallel to segment GA because that was given. Now, when we think about this, why is step 2 important? Why is it important that CA is parallel to GA? So we know that this angle here is congruent to that angle there. So now we know that angle GAC is congruent to angle BCA by the alternate interior angle theorem. They are alternate interior angles. Alternate interior angles are what? They are congruent. So now I've got the one angle mentioned, a second angle mentioned. Now I have to attack the side. So the side would be that CA is congruent to CA. And when we're saying something is congruent to itself, that is the reflexive property. Okay, you have several different homework assignments for tonight. You need to finish up the packet. And your substitute will also pass out a second sheet. Now the packet's divided on the first section, a little bit integrated on the second. The sheet that the substitute will be handing out is very integrated. It has all the different kinds, side, 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 angle, side, hypotenuse, leg, angle, side, angle, 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 side. All different types of problems mixed up within each section. So that'll be great practice for you. And then on Monday, we're going to do more practice, but we're going to use more interesting figures. And I think you'll enjoy that come Monday. Okay, if you're in 4th or 6th, you can go ahead and click the video. For 5th period, I'm going to head back over to the hypotenuse leg we didn't get to yesterday. Let's see if I can find it. I've changed the order of the worksheet, so you may have to hunt through your packet just a bit. Okay, for 5th period, the last thing we should have covered yesterday was the hypotenuse leg congruence theorem. And that says that if we have a right triangle and we have a hypotenuse congruent to a leg, a hypotenuse congruent to a hypotenuse and a leg congruent to a leg, then the two triangles are congruent. So if the hypotenuse and a leg of a right triangle are congruent to a hypotenuse and a leg of another right triangle, then they are congruent. So if we look at this, we do see that played out here. We have two right triangles. That's key. We can't use hypotenuse leg unless we know right triangles. We also see that we have the hypotenuse of each of these triangles marked congruent. Now the other part is this part here, where BC is congruent to itself, and BC is congruent to itself, reflexive property. So since we know that, since BC is congruent to itself because of the reflexive property, then we can prove that these two triangles are congruent. We have a hypotenuse and a leg of one right triangle congruent to a hypotenuse and a leg of the other right triangle. So yes, there is enough in for that picture. Okay, let's look at this example here. Find the proof where it says given AB congruent to DC and BA perpendicular to AC and CD perpendicular to BD. We're asked to prove that these triangles are congruent. So we know what our last step will be. Prove AC congruent to triangle DCB. And now we have to figure out how. So let's go back up and mark our picture. AB is congruent to DC. Tick, tick. BA is perpendicular to AC. Well, if they're perpendicular, that means right angle. And CD is perpendicular to BD. Right angle. Okay, so I see I've got two right triangles in here. How do I show they're perpendicular? Well, we should see that BC is congruent to itself. So if you want, you can mark it congruent to itself. And it looks like it's hypotenuse leg. So hypotenuse leg congruence theorem. Okay, to start a proof, every time we start with a given, AB is congruent to DC. That is given. And there's nothing more I can add to that. I can't expand on that. All right, let's do BA is perpendicular to AC. That was given. But I can expand on this. If they are perpendicular, then it tells me they form a right angle, which is what I need to prove for hypotenuse leg. I have to have a right triangle. So I know that angle CAB is a right angle. Definition of perpendicular lines. When our definition of perpendicular lines tells us that they form a right angle. Now I'll talk about this one. If CD is perpendicular to DB, because I was given that information, then I also know that angle BDC is a right angle because of the definition of perpendicular lines. Now the last thing I've talked about my angle, I've talked about my congruent legs, now I've got to talk about the hypotenuse. So BC is congruent to BC, reflexive property. Oops. Okay, now you ought to be able to finish up all of your worksheets. What you don't finish will become homework. And we'll see you Monday.